Okay. Now, some of you are doing a lot of unnecessary things. You graph a linear function. The first easiest way to graph most linear functions doesn't work for everyone. Okay, like goes through the origin, you're going to have to do something with the slope and so forth. But it works for most situations. If you find the x and the y-intercepts, and you draw a line from the x-intercept through the y-intercept, whatever. So let's say we've got 5x minus 8y equals 25. And y equals negative 2x plus 12. Okay. You don't need to do anything with algebra. You just x-intercept occurs when y equals 0. The y-intercept occurs when x equals 0. Okay, so the first equation, you're going to get 5x minus 8 minus 0 equals 25, and you're very going to quickly get x equals 5, because you're going to have 5x equals 25. You're going to divide by 5, and you're going to get the result. Now you might get a fraction, but whatever the fraction is, it's going to be your value of g divided by your value of a. Because if y is 0, that's what you're going to get. Okay. Then and I did this, I think, pretty thoroughly previously, so. I'm writing this kind of small. If the y-intercept occurs when x equals 0. If x equals 0, in my case, I get negative 8y equals 25, and I can solve that in my head. It's 25 over 8. Negative 25 over 8. So already I've got negative 25 over 8. I've got my first function. Okay, negative 25 over 8 is like negative 3 and an 8. But okay, I'm going to say put negative 4 here. Here's negative 1, negative 2. Here is zero, negative 25 over 8. And the x-intercept is 5, so I'm going to have to modify my scale a little bit. I'm going to redraw graph. And it's probably better if I go ahead and get all the intercepts. You see where I'm headed. Now the graph is scaled so that I can't really locate the y-intercept on the scale that I have. So let's get the second equation. I'm not going to solve it. We let y equal 0. Y equals 0, we get negative 2x plus 12 equals 0. We solve, we get x equals 6. And I'll just make a note. Okay, so that's the x-intercept. Y-intercept which is when x equals 0. Well, if x equals 0, y is 12. Okay. So now we know our intercept, and now I can intelligently set up my y-axis. It needs to go from like -4 up to, I'm going to use 16 up here. And the x-axis will go about here. So let's see. Divide that into 5 points. Yeah, x will go about here. But here's a. Here's 4. Here's 2, 1, etc. And here's -4, -2, -1, etc. So my y-intercept for the first equation is -25 eighths. I'm going to put negative. Ahead of myself. I'll put down 0.0. -25 eighths. Going to go about here. That's the y-intercept. And the x-intercept was 50. So I'll put 8 here. So 4 goes here, 2, 1, etc. Here's 5. And here's my first line. This is the graph 5x minus 8y equals 25. And then the intercepts here, y is 12, well 12 goes about here. So the point 0, 12 is here. And then the point not -60, it's 60. Point is 60, so it goes through the point here. So there's my graph. Your graph is probably going to look fairly similar. Your slope might be greater or less. Slope of this will be less than 1 because b is greater than a. Slope of this will be negative. It's going to be -2. Okay. So what are the coordinates of this point? Well, for my graph, we did, I think, pretty sure we did this last time. This is x approximately equals 5.7 over here. Y approximately equals 1 along this dotted line. And to distinguish these lines, let's go ahead. So this is the process. So we estimate this point. $5.71. Check that out. We plug 5.7 in for x and 1 for y. And this work out real well. 5.7 times 5 minus 8 is going to be somewhat less than 25. But this coordinate is probably a little bit less than 1. Okay, so if I'm a little off in the y coordinates as I'm multiplying y by 8. I mean, I get like 21.5 or 20.5 instead of 25. So it's reasonably close, but not great. If I plug in here, I would get 1 equals -2 times 5.7 plus 12. That works out a little better. It gives me like 2 equals Um, about 0.6, so it's not really right there either. Still reasonable estimate. Now, and you're going to see that if you do a hand-drawn graph. This one didn't come out all that accurate, but it's plausible. So you know that your solution for X and Y is going to be close to 5.71, but maybe off a little bit. Maybe somebody's seeing something I didn't. Now, got a question. Somebody didn't see the negative in front of the 2, right? So you have 2x plus 12, which would give you intercepts. The y-intercept would still be at 12, but the slope would be 2. So the graph, your x-intercept would have been at -6. So the graph would have been like this. Well, the 2 lines would still be coming together, but they come together over here a couple of feet. Okay. And of course, you can get graphs that look like that. It's very possible. So I'm just illustrating it. If you have 2 positive slopes, then it's going to take maybe a little longer to come together unless the slopes are very different. Okay, now we should understand this. Then we want to understand how you would find the exact solution. So let me just check one thing. The one thing as we get deeper and deeper into functions in this course, we're not going to graph functions by plotting a bunch of points. The only functions we graph by plotting a bunch of points are the basic toolkit functions. Okay? Because plotting by points doesn't tell you anything. It tells you where the graph is, that's important. And of course, everybody can do that. Okay? A couple of people wanted to plot a bunch of points. Well, that's fine. It's what you learn to do. And if you've got a really weird function, that's what you're going to have to do. So it's an important skill. In this course, you're not going to get a bunch of functions that you need to plot by points. You're going to get functions that you need to plot as transformations of your basic functions. That's the scheme. Now, there are exceptions to that. Sometimes when you get into polynomial functions, they aren't really transformations to your basic graph. You can spend some time in polynomial and rational functions. But there's still techniques for plotting those functions that don't involve making a big old table. It had to be a pretty big table to show you. They have graphs to do this kind of thing. They go all over the place. Okay. So you really want to avoid having the plot points. Of course, you also have tools, graphic calculators, online Excel, whatever, that allow you to plot these things. So if you really have to see what they look like beyond what you're able to do using basic techniques of this course, you're always going to be able to do it. Okay. So what that last exercise that illustrates is you're going to plot a linear function. Most of the time, you just do the intercepts. Sometimes you have to do an intercept and a slope. And OpenMath show you how to do that. It's not particularly difficult. So we're going to move on now, and we're going to talk about absolute value functions. Now, I don't know that we've actually done the thought of this toolkit function. In the interest of time, I'm just going to make a table. Now, officially, you want to use -1/2 and 1/2. It doesn't add anything because this thing's going to give you a graph, which is just basically 2 straight lines. And you don't even need this many points just to see how it works. You get 2, 1, 0, 1, 2. You notice that if there's a squaring function, it'd be 4, 1, 0, 1, 2 with a 1/4 in there. And for the 1/2 and -1/2. You'd have a parabola with a vertex at the origin. What do you get here? It's real easy to see. I mean, you put -2 here, 2 here, 2 here. And we don't really need -2 because everything's positive. But these are really the only points we need. There's one, here's maybe one more, here's one. And you're going to get these points. And you expand the graph for these points. You get this, which looks a lot like a parabola with a really sharp vertex. And it doesn't curve. So it's like a parabola, except it's not like a parabola. But you can see how if you start deforming this thing by making that point a little less sharp and putting a little curvature on it, well, you get power functions. And we're not going to talk about that right now, because you've got plenty of examples of power functions. And we'll get into that in a week or so. Okay. Here's your absolute value function. Again, see how some deformations and gradual deformations, this could gradually deform it into your quadratic function, your basic square function. We can transform this graph. Okay, so I'm going to ask you to do this. Sketch me a graph, don't make a table. Use transformations, sketch a graph of and to do it using transformation, just ask yourself, if this is a function as opposed to this, where does this point go? Don't plug numbers in. Ask yourself, how does it move? Does it move horizontally? Does it move vertically? Does it move twice as far from the axis? Does it move closer to the axis by some factor? What does it do? Okay, so some people have just a little trouble with this. But again, that could require some review, but on the whole, yeah, most of them look pretty good on this. So let's just be sure we understand what we need to know about transformations. Then we'll apply it to this function. Okay. Okay, there's a quick synopsis. If you place x by x minus h, you move h units horizontally. You add k, you move k units vertically. You multiply by a, you move a times as far from the x-axis. Of course, that means if a is less than one, you actually end up moving closer to the x-axis. And it's a little clumsy to say that, but you should have the idea because you did it for homework, okay? And you also reflect if the A is negative. That means you flip it on the other side of the x-axis. Those are your rules. So this applies to any function f of x in order to graph a times f of x minus h plus k. This is an instance. Okay, that'll take me a minute. Big old clean board, but I've got to pick it up. Okay, so what are we going to do? Well, I'm going to put this into the context of these rules. Okay, so we want to graph graph y equals f of x minus 2 minus 3. Okay. Here's the form. That's a form of vertical stretch, horizontal shift, vertical shift. Okay. So vertical stretch or compression, that's what A is. And in this case, A is going to be 1 because you don't have a number in front of F, x minus H, right? So A is going to be 1. So the graph isn't going to change its shape. It's not going to stretch or compress. H is 2, it's not negative 2 because H is already subtracted. And hopefully you understand in terms of what we did the last few weeks, why that a minus 2 is going to shift the graph to the right. Because X is going to have to be 2 units bigger to give you the same Y value. Okay. And then K equals -3. So no vertical stretch because A equals 1. The horizontal shift is plus 2 because H equals 2. Vertical shift is -3 because K equals -3. It means we're going to take every point of this graph, don't move it further or closer to the axis by some factor. Just shift it 2 units to the right and 3 units down. So we're going to just draw the graph here. Here's our basic graph. I only marked 3 points. There are plenty of points in between I could mark, but the 3 points totally define the graph. You got something we could call a vertex here. So where does the vertex move? Well, the vertex moves 2 units to the right. add 3 units down. This point pushes them point with coordinates 2, -3. It's going to be easy to plot that. You put your -2 here, and -1, your -3 out here, so there we have it. The same thing happens at this point, and move over 2 units. The x coordinate here is 2, so the x coordinate over here is going to be 4. And then it's going to move down 3 units. And the coordinates are going to be 2 plus 2, 2 minus 3, or -1. What did I say? 2 plus 2. Well, this point is 2, 2. So if I move over 2, it's going to go to 2 plus 2. If I move down 3, this 2 is going to go to -1. And over here, same thing is going to happen. I'm going to move over 2 and down 3. And we're going to end up at point. And this point is -2, 2. So where we end up is going to be -2 plus 2, 2 minus 3 equals 0, -1, and that's exactly what it looks like we're going to end up. And here's our transform graph. Make sure you understand all those steps. Probably simpler for this function than it is for any of the other functions. You really only kind of have to look at 3 points. Okay. Now let's just kind of stick with this function. Let's do a absolute value equation. Let's say we want this to equal 6. Okay, now, what's one thing we can do with an equation that we can obviously do here? Well, I'm not sure maybe what to do with this absolute value sign in an equation, but we know if we've got a -3 on this side and we want to keep our x's on this side, we better add 3 to both sides, right? Adding 3 to both sides will simplify the equation. So that we have this. Here we get absolute value of x minus 2 equals 9. Okay. Now we'll discuss this for a second. Well, I got a quick answer to my question, which was 2. My question was how many values of how many numbers have an absolute value that's equal to 9? So people told me 2. And then I asked, okay, what's one of the numbers? -9. That's the answer I got. Okay, so if x minus 2 is -9, then its absolute value is going to be 9. X minus 2 could be -9. And obviously x minus 2 could also be 9. All right. Well, I'm going to just repeat this step and write out the way we work this out. X minus 2 could be -9. X minus 2 could be 9. So this equation splits into two equations. And both of these equations are simple. I mean, it's not solved in your head in about half a second, okay? Now, sometimes they're more complicated. You know, a quadratic expression in here that introduces complication. We're not going to worry about that right now. Okay. The point I'm making is when an absolute value some expression is equal to something else, then that expression is either plus or minus that something else. Okay. Provided that something else isn't negative. Because if it was absolute value of x minus 2 equals -9, how many solutions would we have? How many numbers have an absolute value of -9? None. The absolute value is always positive. So you got to keep that in mind. But the one thing I want you to take away right now is that when you get down to the absolute value of an expression equals 9, you're going to split that into two expressions. This is -9 and this is 9. And then we can all solve it. This obviously gives us x equals 7. Or x equals 11. A question. Okay, so now I'm just pretending to make a mistake there. Y'all believe me? You think I really made the mistake? I think I really made the mistake. Okay. And that should be -7. We had -2 to 9. We do get a -7. Write it down without thinking. Okay. What we're going to check. Now, if it had let me keep it as 7, so I could keep pretending to make the mistake. You plug 7 in here. What's the absolute value of 7 minus 2? It's 5. Okay. And is 5 minus 3 equal to 6? It wouldn't work. Okay. So if we correct that and make it -7, what's absolute value of -7 minus -7 minus 2 is -9. -9 minus 3 is equal to 6. Yeah, that works. Okay. So let's just write out the check. Is this true? Well, absolute value of -9 minus 3 is 6. 9 minus 3 is 6. And we know that's true. So that checks. Okay. Now we could check 11 also. I'm not going to write it out, but 11 minus 2 is 9. So absolute value is 9. Subtract 3 to get 6. So we've solved the equation. Okay. So we could also, approximate the solution with a graph. Now my graph doesn't go far enough. But 6 would be like up here. Okay. If I extend this graph up to 6, is it plausible that my point out here in the x-axis be 11? Okay. Remember, y equals 6 would be up here. This graph would extend and intersect this up here someplace. And then when we look at the x coordinate, it should be about 11, and that makes pretty good sense. Now this branch could go off and intersect y equals 6 over here someplace. Now it's some negative number, and -11 seems like it's plausible. And you could draw the graph and see how that works. So what I'm going to say is if my graph is like this, okay. And y equals 6 up here. And my graph is down here. then come out here, I come down, and it's very plausible that my X coordinate here would be 11, and over here, my X coordinate might be -7. Now, graph isn't particularly accurate, but just show you how that works, because they're graphical connections, everything we're going to look at. Okay. Now, you also have vertical stretches and stuff, but OpenMath will work you through that. And you understand those things pretty well. Just go back and remember what you did with the written assignments and assignments and transformations. Review if you need to. Maybe you also got the text, you can read that. And you really, either before or after doing an OpenMath assignment, you really ought to read the text and take a couple of highlights. As we had a question about the midterm, which will be coming up in about 3 weeks. Okay. And there'll be a major quiz for the end of next week, probably. Okay. And that's kind of a warm up to the midterm. There's a little extra material between major quiz and the midterm. We want to get used to the tests and the nature of the tests. One idea I'm toying with is allowing you to come in with a cheat sheet consisting of no more than 50 characters of sentence. Okay. And it might be 100, might be 50. I'll have to think about what it really ought to be. So right now I'm going to say, why don't you start making yourself out a cheat sheet that you could condense into some number of characters that would tell you what you need to take into the exam. You take it in, you show it to the attendant, staples it to your exam, and make sure it's there when they put it into my folder. Okay. So that's what you get to carry in. I would start reviewing everything we've done and make yourself a cheat sheet. You shouldn't have to put all the details of how you do like 2 to the -2, although I'm going to ask you to show that. You should understand your laws of exponents. You don't have to waste time. You wouldn't have to waste space on your cheat sheet. Okay. Now you might think of writing, okay, b to the -p is 1 over b to the p. It'd be 1, 2, 3, 4, 5, 6, 7 characters. And if you only got 50, you're probably better off remembering that. Okay. You could abbreviate it by just putting 1/b to the p. Okay. And that might be enough of a reminder that tells you, okay, this is how you do a negative exponent. You don't have to write the other side. Okay, or maybe just a 1 and a b to the p, which is only 3 characters without the slash, knowing that there's a slash supposed to be there. Okay, and you understand what I'm telling you? You can symbolize the things you need to remember without writing out all the details of the formula. Okay, if you remember the quadratic formula, but you keep getting the discriminant wrong, maybe you're right, b squared minus 4ac, that'd be 1, 2, 3, 4, 5, 6 characters. Okay, and you know it's going to go under the radical, you know where it's going to go. Or maybe you just never remember the -4ac. Okay, so think about it. Think about how you would create some kind of a limited cheat sheet that reminds you of things that you're most likely to forget. Okay. I can tell you it would not be over 100 characters. It might be 50. Probably wouldn't be less than 50. But right now, I just write out. What are you going to need to remember? Write it out. Keep it in front of you and That way, you're gonna start remembering. Then you're gonna say, okay, what am I still remembering? What am I not gonna need? How can I prune this down? Okay. Okay, now I'm talking about how you might prepare for a test, because there's an epidemic of inability to properly prepare for tests. Okay. Now, looking at your work and looking at what you do, I don't think that there's going to be a big epidemic of that in this class, but you can probably still upgrade your skills. You had some of your prerequisite courses while COVID was going on. Okay. You're going to have deficiencies, although I'm not seeing terrible deficiencies. Okay. But one of your deficiencies is probably going to be you're not as good at preparing for tests as you would be if it hadn't been for all the turmoil in education of COVID. Okay. And you had critical, you probably had one of your algebra courses. Okay. Now, you probably had some important course that you didn't learn as much as you could have. And one of the things you didn't learn is what it takes to prepare for tests. So, one thing I'm saying, read the text. I just said this, but I'll say it on the screen. Read the text. You see this thing that's highlighted and bold with a big border around it, all kinds of decorations around the border, angels and demons and stuff. I guess you doesn't do that anymore. It used to, back in the Middle Ages, we did it all the time. Thing you do, you see that and say, that's important. What's that mean? Okay, I know what that means. But you still write it down because it's really important. Okay. Or maybe, oh, geez, I don't remember what that means. You better read. Then, if it doesn't remind you, better go back to the assignments and practice those things a little bit. Okay. Oh, send me a question. What the heck does that mean? Okay. So you want to start preparing for that. It's coming up in a few weeks, and the preparatory, the major quiz is coming up sooner than that. Okay. Question here about absolute values on the number line. How far is -7 from 12? Well, what's the last digit of your answer? Can you tell me quickly? Okay, not seeing a whole lot of fingers. Okay, seeing a couple. There's wrong number line. Here's a number line. -7 is here, 12 is here. Where's 0? So it's closer to -7 than it is to 12, so maybe there. How far is it from here to here? Last digit. Didn't really count your fingers, but it looked like you had the right number. Looks like the right number was missing. Yeah, I know you got it. Yeah. Okay, well, the last number is 9. From here to here, if you go from here to here, you got to go 7 units to get from here to here. And you got to go another 12 units here. Well, if you got to go 7 units and 12 units, you got to go 19 units, right? So you visualize this on the number line. I don't know how much visualization you've done on the number line or how much you're required to do. Because again, you put technology in your hands, you don't have to think or visualize. Well, I think you probably did have to do some of that, but it might have been a while. And if you're not picturing numbers on a number line, you're certainly capable of it because you're doing well with graphs. Okay, so just adapt it. Right there's 7. Right there's 12. So your total distance is 19. Okay. So I can put 2 arrows in this because it doesn't matter if we go from 12 to -7 or from -7 to 12. You get from 12 to 0, how far do we have to go? How far is just 12 units? Our displacement is -12 units, but Just asking how far. So how far is 12 units here? And from here to here is 12 units. Doesn't matter which direction you're going. And it adds up to 19 units. Well, what's the absolute value of 12 minus 7? That's up. I got some kind of a problem with that 7. What's the absolute value of 12 minus -7? What's the absolute value of -7 minus 12? Okay, now again, I asked for steps. Almost everybody had, I think everybody had the right answer. That one person didn't see the negative here on the 7. They've got the right answer though, assuming it was a 7, not a -7. But to match this picture, you have to have a -7. Okay, so this is going to be absolute value of 12 plus 7, which is the absolute value of 19, which is 19. There are 4 steps here. Or starting from the first 1, 2, 3 steps you actually have to do. And here you have then, this is the absolute value of -19, which equals 19. This actually has fewer steps because you didn't have to worry about the negative and the negative. But you see that this matches the picture. So these expressions, both of these expressions, give you the distance on the number line. So what is, I'm running out of board space, but you think about this for a minute while I'm on the board. Really out. Okay. Gonna have to write it. I'll write it in right color here so you can see it. Okay, on the number line. Here's A, here's B. Now that's not your numbers A and B, that's just any numbers A and B. So what is distance between A and B? That's small, it's supposed to be a question mark up there. What's the distance between A and B? We've got the question. If you didn't understand the question, let me know. And I'll write it out for you. Okay, now. Again, our question is how to get the distance between A and C. So let me write this down. Here's A, here's B. Why did you have a good answer? I gave you a big hint that if you do the same thing with A and B that we did with 12 and -7, you're going to get it. Okay, what did we do with 12 and -7? We subtracted. And it didn't matter whether we did 12 minus -7 or -7 minus 12. Okay, so the distance is absolute value of A minus B, or absolute value of B minus A, because they're both equal. So absolute value of A minus B is the distance between A and B. Okay, so now I'm going to give you a problem. stating this between X and 7 is 14. And see if you get that down kind of quickly because we're almost out of time. So I'll be telling you in a minute or less. Okay, some people did real well with that. It translates pretty directly. The distance between X and 7 is this, and that equals 14. And then we can break this into two equations. X minus 7 equals negative 14, or X minus 7 equals 14. Okay, so that X equals negative 7, or X equals 21. You write that as a solution set. Where is it? Okay. This tells us that we've got negative 7 here. We've got 21. And 7 is right here. We got 7 units here, 7 units here. Too many 7s running around. But the point is that this number is in the middle of these two numbers. Okay. So that's worth seeing, worth looking at. We can also write inequalities. We could write absolute value of X minus 7 is less than 14. Absolute value of X minus 7 is greater than 14. We don't have time to do that, but open math is going to show you that. We'll talk about it next time.